Ever pondered what's deep within Earth's core? Well, let's take a cosmic journey back in time to explore a fascinating theory known as the giant impact hypothesis. This isn't your ordinary science theory. It's a tale of a cataclysmic event that forever changed the face of our planet and gave us our beloved moon. Picture this. About 4.5 billion years ago, in the early chaotic days of our solar system, a Mars-sized rogue protoplanet known as Theia was on a collision course with Earth. Theia, named after the mother of the moon in Greek mythology, didn't just graze past our planet. Oh no, it was a head-on collision, a cosmic fender-bender of epic proportions. This violent impact resulted in a massive explosion, blasting a colossal amount of debris into space. But rather than scattering aimlessly into the cosmos, this debris formed a giant ring around our planet, like a dusty halo. Over time, under the influence of Earth's gravity, this debris began to coalesce, to come together, forming the celestial body we now know as the Moon. The giant impact hypothesis, though it sounds like a science fiction plot, is widely accepted by the scientific community today. It explains why the Moon's composition closely mirrors that of the Earth's outer layers, a similarity that other moon formation theories struggle to account for. But here's where things get even more intriguing. The aftermath of this colossal collision didn't just result in the formation of the Moon. It's believed that some remnants of Theia are still trapped deep within the Earth, hiding in plain sight, influencing our planet's geology and possibly even its history. So, we've got a moon formed from a violent cosmic collision. But what if I told you that's not the end of the story? What if I told you Earth might be hiding remnants of this ancient protoplanet deep within its depths? Exciting, isn't it? Recent research provides some fascinating insights that lend credence to the giant impact hypothesis. It suggests that our planet may be cradling vestiges of Theia, the celestial body believed to have collided with Earth billions of years ago, deep in its core. The most intriguing part: these remnants are not just tiny specks of dust, but massive blobs known as large low-shear velocity provinces, or LLSVPs for short. Nestled under Africa and the Pacific Ocean, these LLSVPs are enormous structures harboring high levels of iron. They constitute around 8% of Earth's mantle volume and 6% of its total volume. Quite substantial, wouldn't you agree? While the existence of these blobs has been known for a while, their origin remained a mystery. Previous studies could not pinpoint where they came from. But this new research makes a compelling case that these LLSVPs are indeed remnants of Theia. This is a monumental discovery, as it not only unravels a part of Earth's history, but also provides a tangible link to an ancient protoplanet that played a crucial role in shaping our world. Theia's collision with Earth was a cataclysmic event, but the energy released didn't penetrate the core, resulting in a cooler core and lower mantle. This allowed the material from Theia to form the LLSVPs instead of fully dissolving into the mantle. The higher iron content in the material slows down seismic waves, making the LLSVPs visible in seismic probing. So, next time you look down at the ground beneath your feet, remember you might just be standing on top of an ancient alien world. But why does any of this matter? Why should we care about some blobs deep within Earth's mantle? Well, let's dive into this. These blobs, or LLSVPs, are not just mere formations within the Earth. They are potentially remnants of a celestial body named Theia that collided with our planet billions of years ago. The impact didn't just create our moon, but may have also significantly influenced Earth's geological history. The researchers suggest that this material from Theia, now residing deep in our planet's mantle, might have played a crucial role in shaping the Earth as we know it. Imagine the continents we stand on, the mountains we marvel at, the oceans we sail across, all potentially influenced by this ancient collision. Further investigation could reveal how this extraterrestrial material influenced plate tectonics, the formation of continents, and other key geological events. This means that our understanding of Earth's history and its geological transformations could be revolutionized. Who knows? Unraveling the mystery of these deep mantle blobs could change everything we thought we knew about our home planet. Get smarter, like, and subscribe